Welcome back to our third lesson on sampling time, the QGIS plugin designed to simplify and automate sampling methods. In this lesson, we dive into the systematic sampling model. Systematic sampling is a powerful and straightforward method that helps to distribute sampling evenly across the study area, ensuring reliable and representative data collection. If you haven't watched the previous videos about the plugin yet, I highly recommend checking them out first, as each one provides different and essential content to fully understand how to use the sampling time. These videos include the Introduction to Sampling Time, Lesson 1 on judgmental sampling, and Lesson 2 on random sampling. Now, let's get started.
Sampling Time, a QGIS plugin, is revolutionizing the sampling process by automating tasks, reducing costs, and increasing efficiency. Supporting judgmental, random, systematic, stratified, and cluster sampling methods, it adapts to any project's needs. A smarter way to sample is now available.
For today's lessons, we are going to be working on the same area as we did in the second lesson related to random sampling. In that lesson, we already saw how to create the sampling area, this yellow line over here. That is very important because we need always a sampling area to be added over here in the select shapefile for sampling. And also we created all these exclusion zones. As you can see, these exclusion zones has different geometries. We have polygons, we have points, and also we have lines. Then if you want to learn how to do all these exclusion zones using the plugin, you can go check that video tutorial where you are going to see how to use this tab over here, generate shapefiles. Then here you can generate the sampling area and also all these exclusion zones. But today we are not going to see that one because we already saw it on the previous lesson. Then we are going to be focused on the model of systematic sampling. The first thing we need to do in order to proceed with the systematic sampling is to add the sampling area in this drop down over here. In this case, it's going to be the sampling area shapefile. Remember that this file has to be a shapefile. And also, if you don't add any shapefile in this option over here, the plugin is not going to work. We need to define a sampling area. Then the second thing we need to do is to add the exclusion zones. Then click this button over here, go to the folder where you have the shapefiles with the exclusion zone. In my case, is this folder over here, exclusion zones, and select all the files you want to add as exclusion zones. In my case, it's going to be the tanks, the pipelines over here, the lamppost is these green dots over here, the facilities, and the buildings. And I'm going to select all these ones. I'm not going to select the sampling area because that is not an exclusion zone. And then I'm going to open, and all these exclusion zones are going to be added over here. Remember that if you want to remove one exclusion zone, just double click on the file, and this one automatically will be removed. Then if you want to add again, just go here, pipes, and open, and this one is going to be added again, as you can see. Remember that it is essential to have the satellite imagery, the sampling area, and all the exclusion zones with the same coordinate reference system in order to avoid any problems or complication with the location of the things. Now, the next step is to add the sample label route. In this case, I'm going to put, for example, soil sample for the 2025, and I'm going to add here this one and press the button Save in order to make sure the plugin is keeping that label to be used on the sampling. Also, we can assign any symbology for the samples. In this case, I'm going to use this symbol over here, and again, press the button Save symbol. Okay, now we are ready to add the parameters for the systematic sample. First, we have to check this box and just read and follow these instructions. Okay, remember in the initiation panel is this panel over here. The only thing is mandatory is the sampling area. The rest of the options are totally optional, okay? The exclusion zones, you can add exclusion zones or you don't need to add it. It depends on your project. Also for the label root, you don't have to add anything here. If you don't add anything, by default, the software is going to assign numbers to the samples from 1 to the total number of samples you have. And the same for the symbology. If you don't add any symbology here, the software is going to add just one circle with a random color for the samples. But if you want to add custom labels, just make sure to write here whatever you want and then press the button save. If you don't press the button save, it's not going to work, okay? And the same for the symbols. If you want to add a specific symbol, just make sure you select the symbol and then press the button save. In other way, it's not going to work. Now we are ready to start introducing the parameters to do the systematic sample. But first, let me explain you one thing. Systematic sampling is a powerful method for collecting samples because it is easy, fast, and very efficient. However, it has one critical weakness: the risk of coinciding with hidden patterns in your data. This phenomenon is known as the periodicity effect. For example, imagine sampling in a farmland systematically every 10 meters, but accidentally align your samples exactly where the conditions repeat. Your results will be misleading. To solve this issue, our sampling time plugin in QGIS introduced 3 advanced and simple to use features. I'm going to explain that ones right away. First, you can define different sample distance along the X and Y axis, breaking the repetitive patterns that may exist horizontally or vertically. Is this option over here. You can define the distance between 2 samples at the X axis and also at the Y axis, horizontal and vertically. Second, you can set an azimuth angle, allowing you to orient your samples according to the project's specific needs, thus avoiding alignments with hidden patterns. Is this option over here, grid azimuth angle. This angle goes from 1 degree to 180 degrees. And third, we've added an innovative zigzag sampling option. This unique approach places your samples in a zigzag pattern, further disrupting potential regular patterns and ensuring highly representative and unbiased data. Then if you check that box over here, you are going to have a zigzag pattern in your systematic sample. All these 3 features together in the sampling time plugin dramatically improve your systematic sampling results, providing scientifically robust and reliable data for your analysis. Let's see how it works. For this first example, we are not going to use any grid azimuth angle. We are going to leave this one as a 0. Then for the X sampling spacing is going to be 30 meters. And for the Y sampling spacing also is going to be 30 meters. All the distance are in meters, okay? Then for the minimum distance between the perimeter and the sample, the perimeter is the sampling area, is going to be 5 meters. And for the minimum distance between one sample and one exclusion zone is going to be 10 meters. Then to start the sampling, we have to press the button start. Now, as you can read over here, click and drag to move the grid. Press enter to confirm the position. Then I press OK. And now, as you can see, we can move this grid. This grid has an azimuth angle of 0 degrees because this one is making a perfect straight line, a perfect vertical line. And also the distance between this sample and this sample is 30 meters, and the distance between this sample and this sample is 30 meters, as we specify here at the interface. 30 meters, and 0 degrees. And also the pattern, as you can see, is a regular one because we didn't apply any zigzag here because we didn't check this box. Now I would like to talk a little bit about the shape of the grid. As you can see, this shape, if I take this one out, is a circle, right? And what's the reason behind that? The reason is because when I was developing the application, it was not clear for me to define where the samples has to start, right? For example, you can take the left corner of the sampling area and specify, for example, 5 meters from the left corner on the X and 5 meters on the left corner for the Y. And then you are going to have 1 point. And then start from that point to add the samples according to the X spacing and Y spacing. But depending of the shape of the area, sometimes that situation could be very complicated because, for example, here you have a left corner that is over here, right? But maybe if the shape is a little bit weird, you are going to have things over here or things over here, a very weird shape that when you add the samples is not covering 100%. And because of that, what I decided to do is to take the sampling area, rotate this sampling area 360 degrees, and with that area, provide a buffer, and inside the sampling area rotated 360 degrees plus the buffer, add the samples inside. That's because we have a circle for the grid. In this way, we are going to have always the guarantee that we have samples inside of the sampling area. Because even, for example, can you imagine if you have a circle, how you specify to the software where do you want to start to do the samples, right? Because there is no corners. You cannot say in this point, in this corner. It's very difficult to specify. Then that's the reason because I decided first to make a perfect circle to have the guarantee that we have coverage for all the area with samples, and also giving the opportunity to the user to decide where they want to place the grid. And I think that is pretty interesting, right? Because at the end, for example, as you can see, this line over here is touching the perimeter of the sampling area. Even we decided to add 5 meters here between the sample and the perimeter. If you add these samples here very close to the perimeter, they are not going to be added, right? Because this sample between the distance between here to here, if the distance is less than 5 meters, you are not going to see these samples because they are going to be on a exclusion zone, right? Defined because of the perimeter has to be from the perimeter to the sample 5 meters. Then the first samples you are going to have is going to be this line over here. Then I think these options, to move the grid and also to have a very big area with all the samples, give you a lot of different opportunities, to maximize the sample for your area. And that's the thought behind of the design of the grid for the systematic sample. Then once we decide where we want to have the grid, just press enter on your keyboard. And it says the grid set, left click to add samples, right click to remove them. Press save to generate the final shapefile. Then we press OK here. As you can see, now we have these samples in this position. Now, if we want to remove one sample, we can do right click with the mouse on the sample, and this sample is going to be removed. If we want to add one sample, just left click on your mouse and you can add the sample. You can add samples wherever you want. Here Here we cannot add samples because it's very close to an exclusion zone, and the minimum distance has to be 10 meters. That's because you cannot add the sample there. Even if you want to add a sample here, it's not going to be allowed because it's an exclusion zone. And in addition, if you want to add one sample very close to the perimeter, it's going to say it's very close to the perimeter. Minimum distance has to be 5 meters, okay? But if you want to add one sample here, you can add it with left click, and if you want to remove it, right click on your mouse. Also, if you want to add one sample outside of the sampling area, it's not allowed. The sampling point is outside the sampling area. That's because if you want to do that one, you have to check this box over here. Once you check it, now you can add the sample outside. As you can see, now it's allowed. More things. As you can see, the samples adapt perfectly to the exclusion zones. You know, here we have a sample, but here we don't have that sample because this is inside of a exclusion zone. And here also we don't have the sample because it's very close to the perimeter of the exclusion zone. And as we define, that one has to be 10 meters of distance. We don't have any sample here. We don't have any sample here. And if we check over here, for example, you can see here in this line of samples, we don't have samples because they are very close to exclusion zones. Then we don't have samples in this line over here. The lines goes from here, and as you can see here, no samples because these are exclusion zones, or the samples are very close to exclusion zones. The same happens over here. You can see in this area, we don't have any sample because we have this exclusion zone, and also we have the pipeline over here. There is an exclusion zone. And also for the perimeter, it happens the same, right? Here, I think we are very close to the perimeter area. Then we don't have samples here because from here to here is 30 meters. Well, maybe it's going to be outside already. But, you know, the exclusion zones is perfectly controlled by the values you add here for the perimeter and for the exclusion zones. When you finish with the sampling process, just press the button, create shapefile, then press save, select a folder, desktop, QGIS Plugin, and I'm going to select here systematic, select folder, then select a name. I'm going to leave this one by default, okay, and now the samples has been added, then okay, if I take this one here, you are going to see all the samples that we added systematically. Then if you go to the attribute table, open the attribute table, you are going to see that you have a table with all the IDs for the total number of samples, and in this case is 55 samples. We have the label with the root we added plus one number from 1 to 55 samples. And also we have the X and Y coordinates for each of these samples. Now you have this new layer that is a shapefile that if you go to the folder, desktop, we save in this folder, QGIS Plugin, systematic, and it's this file over here with all the information for the coordinates, for the shape, etc. Also now you can edit this layer as any other layer. If you go to properties, go to symbol here, check this one. This one is a SVG marker, but can be edited. Then for example, for the fill color, we can add here a red color. And also for the line, we can add a blue. Then apply. And as you can see, now we have a different symbology, or black color. Looks better, okay? Then if you put the satellite imagery, you are going to see that you have your samples over there. Also, you can add on the map the labels. Then go here, label, select here single label, select the column you want to represent. In this case, we have the ID. I want the samples. Then apply. And now you have the labels. Then you can customize how you want to see that one, right? Apply. That's up to you. There are a lot of samples here. Then you have to make labels smaller, whatever you want, right? That's how you want to present the map. In this case, at the moment, I'm not want to use any labels for the samples, apply, and I'm going to leave like that. Now we are going to see how to use the other features. Then I'm going to take this one out, and we are going to start a new one. Then in this case, I'm going to add an angle of, for example, 15 degrees. I'm going to put this one with 20 meters, and this one's with 40 meters, for example. You have to be realistic with these values over here. If you put here a very small values, the software is going to crash because it's going to be too much information in a very small area, and it's going to take longer, and at the end it's going to crash. Then you have to be realistic with the values you add over here in order to avoid the software crash, right? Then here we can add, for example, 10 meters, and to the exclusion zones, I want a distance of 15 meters. And in this case, I'm going to add the zigzag. Then start. Okay. And as you can see now, these lines has an azimuth angle of 15 degrees. That's the angle we added here, 15 degrees, right? And also, sorry, I took it. And also the distance between the X spacing is this distance over here is 20 meters. And for the Y is this distance over here is 40 meters. Then we can move whatever we want. Press enter to fix the grid. And okay. Now we can add also samples outside. But I would like to change this one for this symbology. Save. Okay. And also I'm going to change the label route for something different. I'm going to put here, for example, TR. And this one is going to be 2024. And this one here, just to do something different, right? Then save. Okay. I'm going to add some samples outside. This one's over here. And as we already did whatever we want to do, just save. Select the folder, systematic again, save. Here is going to be a different name, 01. Okay. And that's it. Now we created the new systematic sample. Even it looks pretty, the lines pretty weird. That's the design we decided, right? And if the lines looks pretty weird, it's because of the exclusion zones, and also because of the zigzag pattern that we decided to check it, that we are going to review later. Now, for example, if we do here a buffer, I mean a buffer for the tank area. For example, let's go here to Vector, Geoprocessing Tools, Buffer. And here we are going to select the tank shapefile. Then here we're going to add a distance of 15 meters. That's the minimum distance that we want from the tanks to the samples to be avoided by placing any sample over that buffer area. Then we want 50 segments to make the shape of the buffer totally round. Then if we run this one, close, and then we add this one to the bottom. Now we have the buffer that we added here, right? We add minimum distance from the exclusion zones to the samples has to be at least 15 meters. That's the distance from the tank to here, at least 15 meters. And as you can see, no one of the samples is inside of that buffer areas. And the same happen if we take another exclusion zone. For example, let's go to do with the buildings. Then select the layer here, run, close, and put this one on the bottom. And as you can see, again, no one of the samples is inside of this buffer exclusion area. And that's what the buffer you are adding here is doing, right? To avoid to place any sample that is inside of these 15 meters. Then, as same as the other file, if we take here the buffers and we go to the attribute table of this file, you're going to see that we have the same columns. We have the ID, we have the samples with the, in this case, open attribute table. The label is the same as the one we added at the beginning. Then to work that one properly, what we have to do is reset the plugin, right? Then if we go here, we can reset the plugin. Yes. Okay. Now we have to add all the information again. I want the sample area. I want to add the exclusion zones here. Need to go to the desktop. And this one here. Lesson 2, exclusion zones. I'm going to add this one, this one, this one, this one, and this one. Okay. Now here I can add a different label route. For example, I'm going to add this one. Here, 2025. Then for the symbology, I'm going to add this one in this case, save. And I'm going to add a different example. Then this one, okay. Here I'm going to add 30. For example, 10 by 10 is going to be a lot of samples. Or 20 by 20, better. 20 by 20. Then here I'm going to add 5 meters, 10 meters here. I'm going to select this one. Now we are going to see better the zigzag pattern because I'm not going to add any angle. Then a star. Okay. Now I'm going to place this one, for example, over here. You are going to see that if these points are very close to the perimeter, we add 5 meters. They are not going to be added. Then I press enter to fix the grid. You see, it's not being added. And okay. And now you can see the zigzag, right? That's the zigzag pattern. Then in this case, what the software is doing is moving this point to the middle, right? Then it's like, for example, here we can measure the distance, but let me finish first the samples. Then save. Select the folder. In this case, I'm going to select a different folder. Go to the desktop. This one, systematic, select, and it's going to be the number 303. Okay. And okay. Now, if we go close, I'm going to close this one. And we take this tool over here to measure the line. We can see that the distance on the y-axis from here to here is 20 meters. You can see, you can see the information right here. But if we measure the distance from here to here, is 40 meters. It's double. But we didn't add that information here because here we have 20 and 20. But the zigzag, what it's doing is taking the samples, the line, for example, this line, and make a displacement. And then it respects the distance at the y-axis from here to here, 20 meters. But for the x-axis, the distance of 20 meters is from here to the middle over here. That's what the zigzag is doing. And the goal of all these tools, you know, the azimuth angle, the selecting the spacing you want and make the zigzag pattern is to avoid the effect that we call at the beginning, right? The periodicity, right? If you have any phenomenon here that you want to analyze and you know the phenomenon is following a repetitive pattern in any direction and you want to break that pattern in order to have representative samples of the studying area, you can use all these tools that it was designed, to use the systematic sampling in a proper way. Well, that's it for today. Thank you very much for watching this video tutorial, and see you on the next one, where we are going to be talking about stratified sampling.